Welcome all to Work, Energy and Power Class 5, in which we'll discuss about equilibrium. So the meaning of equilibrium is nothing but if we are considering the net force acting on an object is equal to 0, or if the net torque acting on this object is also equal to 0, then we can say that this object is in equilibrium. So the condition for equilibrium is net force should be equal to 0 and net torque is equal to 0. About torque, we'll discuss in detail about the topic rotational motion. Now basically we are talking only about the force acting on the object. So if assume that torque is equal to 0 and if the force is also equal to 0, then the object is said to be in equilibrium. Now if you are considering a situation in which the forces acting on the object is only conservative, or if an object is kept in conservative force field where only conservative forces are existing, so we can say that the force exerted by the conservative force should be equal to 0, or we know that the conservative force we can find out from potential energy, that is minus of du by dr will give the value of force acting on it. So the value of this net force is equal to 0, or we can say that the value of minus of du by dr should be equal to 0. Then we can say that the object is in equilibrium. So if we are drawing a graph which is showing the relation between variation of this potential energy with respect to its position, let's say r, and over here we can observe that du by dr is representing nothing but slope of this potential energy versus position graph. So we can say that for equilibrium the value of this slope of this graph should be equal to 0. So if you are getting the shape of graph something like this, so we can say that at this point the value of slope of this graph is 0, and over here also the value of slope is equal to 0. So at these points the value of du by dr is equal to 0. So we can say that at these points, let's say at point A and point B, particle is in equilibrium. Now we'll discuss about different type of equilibrium. First one is nothing but a stable equilibrium. The meaning of stable equilibrium is that first condition is the net force should be equal to 0, and for stable equilibrium, if a particle is displaced from its equilibrium position, then the restoring forces will take the particle back to equilibrium position. Then that type of equilibrium we call it as nothing but a stable equilibrium. As an example, suppose if I am just considering a positive charge particle over here, let's say charge q, and another positive charge particle over here, take it as q, and if you are taking another positive charge particle, let's say magnitude q, is kept exactly in between these two charges. So you might be knowing that this positive charge is going to repel this one, and this positive charge is going to repel this one. As the value of net force acting on this one is equal to 0, this charge particle, we can say that at this instant this is in equilibrium. Now if you are displacing this charge particle from here towards right, then the force of repulsion between this object and this positive charge will increase, or if you are displacing it towards right, then there will be a larger force acting towards left. Because of that, it will take the particle back to its equilibrium position. So we can say that along this x-axis, this positive charge particle is in stable equilibrium. So the condition for stable equilibrium is if you are displacing the object from its mean position, and if the object is able to come back to its original position, then we can say that it is in stable equilibrium. So one condition we can write definitely, that is the value of net force acting on this one should be equal to 0, or we can say that the value of du divided by dr should be equal to 0. So if you are just drawing a graph which is showing the relation between potential energy of a particle as a function of its position vector. So let's say the shape of this graph is something like this. So if you are considering that the object is in stable equilibrium, that means if the object is at this particular point, and if you are displacing this object towards right, then we can observe that the value of force acting on this object is nothing but F is equal to minus of du divided by dr. So assume that the object was at its minimum potential energy, and from here we displace a particle towards right. So now assume that the particle is over here. At this instant we can find out what about the value of slope, and you can observe that this slope angle is less than 90 degree. That means the force acting on this object is negative, because du by dr is nothing but slope. As slope is positive, f is negative. That means force is acting along the negative direction of r. Or if you are displacing the object towards right, the restoring force is acting towards left, which will take the particle back to its equilibrium position. So this we can take it as an example for its stable equilibrium. Or we can assume that from its equilibrium position, if we displace the object towards left, then we can observe that the value of slope over here is negative, or the value of du by dr is negative. If du by dr is negative, then f is positive. That means force is going to act along the positive direction of r. So it will take the particle back to its equilibrium position. So we can say that the condition for stable equilibrium is that at stable equilibrium, potential energy is minimum, because at minima we can say that the value of d square u divided by dr square should be equal to a positive. So that we discussed in basic mathematics, the condition for maxima or minima. If we are at minima, then the value of d square u by dr square should be a positive value. So at stable equilibrium, potential energy is minimum, or when displaced from its equilibrium position, restoring forces start acting on the object, which has a tendency to bring back object to its equilibrium position. At stable equilibrium, potential energy is minimum compared to its neighborhood points. So the condition for minima is d square u divided by dr square should be equal to positive. So this we can take it as the condition for stable equilibrium. So remember these important things related to stable equilibrium. When displaced from its equilibrium position, restoring force starts acting on the object, which has a tendency to bring the object back to its equilibrium position. At stable equilibrium, potential energy is minimum compared to its neighborhood points. Now we'll discuss about this unstable equilibrium. Unstable equilibrium means the first condition is that the force acting on that object should be equal to 0. But if you are displacing the object from its equilibrium position, the forces will try to take the particle away from equilibrium position. It will not take the particle back to its equilibrium position. Then we call it as nothing but an unstable equilibrium. We can take an example for it. So assume that we are having a positive charge over here, take it as q, and another positive charge, a similar charge q over here. And in between these two positive charge, exactly in between them, assume that I am just keeping a negative charge minus q. Now this positive charge is going to attract this negative charge, and this positive charge is also going to attract this negative charge. So we can say that at this instant, the net force acting on this negative charge is 0, so it is an equilibrium. But if you are displacing this negative charge towards left, so the force of attraction between this negative charge and the charge on left will increase, and force of attraction between this negative charge and the charge on the right side will decrease. So if you are displacing this object towards left, or negative charge towards left, it is going to move towards left. Or if you are displacing the object towards right, then the net force will act towards right. It will take the particle away from equilibrium position. So we can say that at this instant, this negative charge along x-axis, this negative charge is in unstable equilibrium. Or we can represent the same thing by using that potential energy versus distance graph. If the shape of potential energy versus distance graph is something like this, so at this point we know that at point A and at point B the value of du by dr is equal to 0, so the net force acting on the particle is 0. Now assume that we are at point A, and if we are displacing the particle from point A to some distance along the positive x-axis, then we can say that the slope of this graph over here, this theta is greater than 90. That means the value of the equation for force is minus of du divided by dr. Over here du by dr, or the slope of this graph, is negative. So the value of f becomes positive, F positive means force will act towards right. So if we are displacing the object towards right, force is also acting towards right. So it will not take the particle back to its equilibrium position. Or we can consider that if we displace the particle towards left. So at this instant, we can identify the value of slope angle over here. So which is less than 90 degree. That means du by dr is positive. So if du by dr is positive, then F is negative, means force is acting towards left. So if we displace a particle towards left, the force is acting towards left. So it will take the particle away from equilibrium position. So this is representing an unstable equilibrium position. Or one more thing we can observe, that at unstable equilibrium, this potential energy is maxima. And we know the condition for maxima, that is the value of d square u divided by dr square should be negative. So this is the condition for maxima or unstable equilibrium, because at unstable equilibrium, potential energy is maximum. So remember that in unstable equilibrium, when displaced from its equilibrium position, net force starts acting on the object and moves the body in the direction of displacement or away from equilibrium position. And in unstable equilibrium, potential energy is maximum as compared to its neighborhood points. Now we'll discuss about neutral equilibrium. Neutral equilibrium means when displaced from its equilibrium position, the object has neither the tendency to come back or nor to move away from equilibrium position. Then that type of equilibrium, we call it as nothing but a neutral equilibrium. Or we can say that there is no change in potential energy of object. Potential energy will remain constant. So if I am just drawing a graph which is showing the relation between potential energy with respect to its position vector. Let's say the shape of this graph is something like this. So if you are considering the object at a point somewhere over here at point A. So if you are displacing the object towards right, or if you are displacing the object towards left, then in both the situation the force acting on the object is 0, as the value of du by dr is equal to 0. Or we can say that the potential energy will remain constant. So this type of equilibrium, we call it as nothing but neutral equilibrium. So if you are just considering point B where the potential energy was maximum, that is known as unstable equilibrium. If you are considering point C where the potential energy is minimum, is known as the condition for a stable equilibrium. And point A where the potential energy is not changing, that is known as the condition for its neutral equilibrium. At neutral equilibrium, as the value of potential energy is not changing, so the value of d square u divided by dr square should be equal to 0. So remember that when displaced from its equilibrium position, the body has neither the tendency to come back nor to move away from equilibrium position. The potential energy remains constant even if the body is displaced from its equilibrium position. So once again, just remember that when the object is at maxima or at maximum potential energy, then the object is in unstable equilibrium. So over here the object is in unstable equilibrium. And when the object is at minimum potential energy, then the object is in stable equilibrium. And when the object is with a constant potential energy, then the object is said to be in neutral equilibrium. Hope so that you understood whatever the things we discussed in this class. If you are having any doubt, please contact. Thank you.